So the S.T.A.L.K.E.R 2 Phase 2 of the SDK should be dropping here in the next 24 hours. Beta testers have had our hands on it for at least a few weeks, and there are a ton of new features and improvements added that should make creating mods in the SDK a lot smoother, a lot nicer, faster, more efficient. So let's jump right into the major changes that I'm going to cover here today. The first one is it's faster, much faster. Starting up the SDK, previously I saw on my system about an average of 3.5 minutes, and now it generally starts up well under a minute, usually around an average of 40 seconds as I've been testing it. And probably what's even more important than the startup speed is the packaging speed. Phase 1, I saw an average of 5 minutes. I was hearing other beta testers having averages are way longer than that, but all of us are seeing packaging in less than a minute. So I'm seeing an average of 50 seconds, and that is a massive improvement versus what we were seeing before. While speed is all well and good, there's still, in the first phase of the SDK, were a few things that were missing. So now, one of the biggest things that we got was a new subsystem that handles loading blueprint logic for mods that utilize the Unreal Engine blueprint graphs and scripting. This is huge. This basically means that we can create blueprint logic at any time, which opens up a ton of new effects and changes that we can apply to the game at runtime. With this new mod subsystem, in order to run blueprint logic, it is no longer required to have an external blueprint mod loader because the ModWorldSubsystem does the work of what we would normally use a blueprint mod loader for. UE4SS and Simple Mod Loader, while those were great while we needed them, we no longer need them. That just means we can release mods without prerequisites. Configuration editing and configuration files. One of the biggest changes that we're seeing now in patch 1.6 going forward is that the vast majority of raw configuration or plain text configuration files are now going to be encoded at rest, and they're going to be no longer plain text files. I think I mentioned in a previous video how surprised I was when I actually got my hands on the game files of how much of the configurations were in plain text. It seems like now, with these files being binary and pre-compiled instead of needing to be loaded and interpreted at runtime, we're going to see a much more efficient game with less demand, particularly on CPU and hard drive and memory. But the downside from the modding community standpoint is that it's a little bit more difficult to see what is in those files. We still have the ability, it's just we can't go into the game without the SDK and see what these config files contain. Another big addition that we have now is that we can now edit non-prototype configs, and by that I mean config files that they don't contain SID prototypes. So the biggest one I think a lot of folks have been wanting to mod since day one was the core variables config file, which has a lot of really juicy content in it. With the new structure of the config files, we have two new operators that we previously didn't have. bpatch, which intends to make the process of setting up config changes that don't conflict with other mods easier. Previously, we were limited to having to use the ref URL ref key pattern, wherein we refer to the original config file that we actually want to modify part of it with the ref URL. And then with the ref key, we'd modify or point to the node that we want to make a change to. So that could, in some scenarios, be a little bit confusing of exactly what we need to point to. But now with bpatch, that should be a lot simpler. And then also we have a operator called remove node, which if we just wanted to get rid of a particular structure or node, we can just use that instead of having to rewrite the whole file. And lastly, the mod structure has changed from the Phase 1 SDK to the Phase 2 SDK. We no longer have mods stored in plugin folders. We actually have them stored in mod folders. So over here, if we look at, like I have my mods here in the mods folder. When we go to create a new mod, it will show up in the mods folder, which is completely separate from the plugins. So now we don't have to do anything to differentiate what is a native plugin versus what is mod content that we created ourselves. We now have the ability to package loose files. And when we talk about loose files, we're primarily talking about configuration and INI files and things like that. Whereas previously we couldn't really do that through the SDK, at least very easily. Now all we have to do is modify our config file, put it into the content folder of our mod, just making sure it has the same folder structure that it normally has in the game, and then it will package perfectly fine. And checking out assets, even though we no longer have our mods created under plugins, checking out an asset is still the same. If we have a mod active and we go to check out an asset, that is going to be within our mods folder where a checked out asset will end up. So let's real quickly look at their examples of how to use some of these. So the first one I'm going to cover is ModWorldSubsystem. So how do we use that? And then I'll go over configs and how to actually package a config mod, because it is a little bit different now. So let's get started off with blueprints. All right, so let's do a quick walkthrough of how to use the ModWorldSubsystem in a blueprint mod. So we're going to create a new mod. The first thing we want to do is we want to right-click and create a blueprint class. And now normally if you've watched any other of my blueprint tutorials, previously we'd start off with blueprint actor. But we're going to do something different. We're actually going to use the ModWorldSubsystem as our primary class of this blueprint actor. So I'm just going to go ahead and under all classes, just type in ModWorld. There we go. We want this one at the very bottom right here. So we click on that, select, and now we're going to name it BP for blueprint, and then MWSS for ModWorldSubsystem, and then test. You can name this anything you want. So double click on it and open it up. And one thing you'll notice from opening up a blueprint actor, what is different is we don't have our default 3 events, begin, play, overlap, and event tick. But what we want to do is we want to add the on begin play equivalent for ModWorldSubsystem. And we can find it in here. It's actually called on world begin play. And we have the on tick here as well. But if we just go functions, hover over that, say override on world begin play. So we'll have this event on world begin play. We could do pretty much whatever we want with this from this point forward and treat it just like an actor blueprint's begin play event. So what I want to do in this just real quick test mod, don't want this to go too long in this video, is I'm just going to create a widget, put it on screen just so that we know that this blueprint logic has been initiated. Real quick, I'm going to go back and I'm going to create a new asset, user interface, widget blueprint. Open up this guy. We're going to make a very simple widget. Now we're just going to have a canvas and some text. A simple text widget. And I'm not going to do anything fancy in here. I'm just going to have it centered on the screen. And I'm going to have it say something like that. Now I got this centered on the screen, or it was centered. There we go. Compile, save. Now I can go back to our widget blueprint, create widget. We're going to choose the widget blueprint we just created. Add to viewport. And that should be enough. So if we save this, and we test it out in the play and editor, there we go. That's what we would expect to see. This is nothing particularly special, but we know it works in the editor. Let's go ahead and package this and make sure if the same thing happens in the game without help from Simple Mod Loader or UE4SS. So I'm going to go ahead and stop the play and editor. And we're going to package the mod. Once it's done, we can find where it's packaged. We can just right-click on any of these assets, say Show in Explorer, and then we're just going to go to the Stalker 2 folder right under the SDK root, and then Save Mods Staged. We're going to find the name of the mod that we just created, ModWorldSSTest. We're going to go through all these folders until we get to Windows. I'm just going to copy those three and then put them into my tilde mods of the actual tilde mods folder, rather, of the actual game. So now let's start the game up. Oh, well, I'm actually kind of glad this happened. I know what happened here, and I'll explain it here in a couple seconds. If you notice, this mod actually crashed the game during the shader compiling, and there is a reason for that. So I'm going to go ahead and close this. It does actually give me an opportunity to explain one of the nicer features of the ModWorldSubsystem, because this is a common thing that can happen with Blueprint mods. Back in the SDK, let's go ahead and open back up our bpmwss test, and to explain what happened and why we had a crash. What we're attempting to do here is every time this begin play occurs, we're attempting to immediately create an instance of my widget blueprint and then add it to the viewport. Well, there's a problem with that whenever the game is not in the world map, or i.e. you're not playing the actual game in the open world. So when you're in the main menu or the loading screen, there's no viewport that we have access to. So one of the nice features of event on world begin play is that it provides you with this world object reference here, which we can use to test if we're in the right level, so to speak, world or level, you can call it either one, to where we actually want our logic to run. So I know that from experience and testing this, that we only want our code to run when we are in the world map, world partition. So what we can do is we can grab this world reference and we can say, actually, first let's get the display name of the world, which we would expect to be world map WP. I'm going to test it and say, is this equal to? And then on the other part of this test, I'm going to say world map underscore WP. And that is the name of the level, the world partition level for the main game. Now, after that, I'm going to put a branch in here and say that we only want to proceed if this is true. So if the world we are currently in has this name, then we want everything else to run. Otherwise, we don't want it to do anything. So now we'll compile, save, package that again. While that's packaging, you can look up all the levels in the game if you're curious. There are quite a few of them, but the big one, which I'm in right now, by the way, if you look, you can see that this world map WP is loaded. This is the main game. This is the only level that we want that blueprint code to run in. There we go. So we'll get the newly packaged mod, pop it back in here, and then start the game again. And there we go. So basically, we prevented it from trying to do anything while it's compiling shaders, which would normally cause a crash. There we go. All right, so let's talk about the changes to the config files in 1.6 going forward. So if you open up fmodel and you look in the Stalker 2 content, game light, game data folder, and subfolders, you're going to see something different from what we saw before. We're going to see a lot of these CFG files now have a .bin or binary extension after them. So those we're not going to be able to open up in fmodel and inspect their values. In fact, if we double click on them, fmodel is just not going to show anything. There are still going to be some configuration files that are plain text, such as this asset library, but all of the ones that have the .bin, we are not going to be able to view outside of the SDK going forward. In order to view what is in these configuration files, you will instead open up a new File Explorer window and go to your SDK root folder and follow down to Stalker 2, Content, Game Light, and Game Data. And here we're going to see with the SDK, we're going to have the non-encoded or basically uncompiled raw text configuration file. So in here, we can actually view the contents of the configuration files that make up the configuration of the game. So what I generally recommend doing is opening up this folder, this GameLight Game Data folder in VS Code. So I'm going to put this over here on the left. And in here, we can click on and open up any files that we previously could not see in fmodel. So for example, let's take a look at object prototypes, because it's an interesting one. There's a lot of interesting values in here. And I'm going to open up the player and not the first node here. There's two nodes in object prototypes. There's a node that is the first index or the 0th index, and then there's the player. So in here, we're going to have quite a bit of the attributes that determine how the player, basically how powerful the player is, how fast the player is, how high they can jump, etc. We're going to use this as an example of how to use the new bpatch feature. Let's look for something that we want to modify. This player node is around, it's a little over 200 and something lines. So let's just pick a few things because we don't want to rewrite this whole thing. Let's maybe change the run speed, and we'll just start off with that for now. What we're going to now do is create a new file, and I am going to start by going to the ZoneKit and creating a brand new mod. I'm just going to call it Skiff Run Fast. I'm not going to put anything in this mod other than a single configuration file. So I don't really need to do anything inside of the SDK with its folders. What I am going to do, however, is right-click on that new in mods, where I created my mod. Just right-click on that folder, and then click on Show in Explorer. So once I have this open, I'm going to go ahead and right-click and open that with VS Code. I'm using VS Code, but you can use, text editor if you really wanted to. I just find it's helpful. Inside of this content, what we're going to have to do is we're going to have to ensure that we are putting our modified configuration file into a folder that is one level up from the target configuration file we're trying to modify, that has the same name as the configuration file without the extension. So in the case of object prototypes, that actually already exists for us in here. However, we just need to mimic that within the structure of our mod. So what I'm going to do is I'm going to create another folder under content, and I'm going to call it, so I'm going to mimic this path here, content, game light, game data, object prototypes. So I need to create those three folders. Now I can right click on that and say new file. And I'm just going to call this the name of the configuration file that I am trying to edit, followed by underscore patch, and then the name of my mod, followed by .cfg as the file extension. Now, this exact pattern is not implicitly required. It's just a good best practice, especially when we have multiple mods that are trying to modify the exact same root configuration file. This just helps us keep all of our mods separate and not colliding with each other. So inside of here, what I am going to do is look at the top level node that I want to modify. In this case, it's player. So that's going to be the first line. And then just like we have over here on the left, I'm going to go space, colon, space, struct.begin. And then, because sometimes I forget, I'm going to go struct.end because each one of these struct begins has to have a matching struct.end. Previously, what we would do is we would use ref URL equals, and then the relative path to whatever the original configuration file is we're trying to modify. So that'd be one folder up and obj prototypes.cfg, and then a semicolon and ref key equals player. So this is what we would use previously. Now, what bpatch does is we don't even have to use this anymore. All we have to do is just type in bpatch, and that will tell the interpreter for these configuration files that we want to modify the node for the original file, which it identifies by the folder name that we are currently in, and that the node we have in here will be the same node we want to target in our original file. The nice thing about this is that we don't have to copy everything and then paste it over, especially if you're only wanting to change one thing. We just want this sprint speed right here. So this sprint speed exists within another node underneath player. So we're going to copy the name of that node that contains it. We're going to paste that in here and make sure that we put another, because we added a struct begin, we need to put another struct.end. And then we can copy sprint speed and paste that in as well. Now here is one other difference that we're going to need to do from how we used to handle the ref URL ref key pattern. If we were using ref URL ref key instead of bpatch, this would technically work. However, when we're using bpatch, we also have to tell it if we are modifying any other structs beneath it, that every time we have a struct up again, unless we want to change this movement params over here to the left to only contain one thing, then we need to tell it to also patch this struct. Otherwise, what will happen if we leave this as it is that in the game, we'll have movement params, and it'll have a single value of, or have a single property of sprint speed being equal to whatever we're going to make it. But all these other nodes will be deleted. So the effect would be that, well, we no longer have a lookup or turn rate, so you won't be able to look around. There'll be no jump coefficient, so I believe you'll still be able to jump, but it might be a little bit wonky. Then you won't be able to walk or do anything other than sprint. Instead of that, we actually want to put another bpatch in here, which tells the interpreter that, okay, we don't want to completely replace movement params. We just want to target this one node that already, or excuse me, this one property that exists within movement params, and leave everything else as is. So now I'm going to change this to, let's say, 20 meters per second instead of 8.2 meters per second. Save that. And when we go back to ZoneKit, we can see that under that new mod we created, we have game light, game data, object prototype. So we're not going to see the file, even though it does technically exist. We can verify it by right-clicking on object prototype folder and go show and explore, and sure enough, it is. So when we go to package, this mod will literally contain only one file, and it'll be that config file in this file structure. So now I'm going to go back to the location of that file. I'm going to go back to the S.T.A.L.K.E.R 2 directory under the SDK root. Go to save mods, staged, find the, what did I call it? Skiff run fast. There we go. Windows S.T.A.L.K.E.R 2 mods, content packs, Windows, copy all three of these. Then go to my mods directory, paste that in here, and then run the game. And let's see if we have that extra speed now. Oh yeah. Seems like 20 meters per second to me. Now, you may not notice an immediate change. Sometimes you will have to go in and out of a hub area to actually get it to change the speed. So just give it, run around for 30 seconds to a minute, go to a hub area, go out of a hub area, and that should be enough to change your run speed. So now let's look at how we now modify non-prototype configurations. Most configuration files are going to end in prototypes. We can use bpatch and this pattern right here. It's a slightly different pattern when we're working with the non-prototype config file. So a good example of that is core variables. So let's take a look at core variables and let's find something to change. Let's modify climb speed. This, I believe, will change how fast we climb up and down ladders. Oh my God, there's a ladder note right there, so that would make sense. Let's go ahead and go back to the game data folder in our mod structure, and let's create a new file in here. Core variables, when we're modifying prototypes, we use the subfolder that I explained earlier, but when we're modifying non-prototype configuration files, we actually put it in the same directory. So I'm going to need to create a file called core variables, and it's the extension that's going to be different. The extension pattern that we use, one, I'm going to create a new file here in game data. I'm going to call it core variables, which is the exact same name of the .cfg I want to modify. And the extension is going to be CFG. And then here's where we're going to add in something different. We're going to do the same thing where we have patch underscore and then the name of our mod. So instead of using the file name to put the underscore patch in our mod name, when we're working with non-prototypes, we use the extension instead. So in here, we're going to look at the structure of core variables. So we're going to modify the climb up and down speed. So I'm going to copy those two, paste them over here, and then we're going to look at what is the structure of the nodes that contain it. So when I'm looking at this, we have climb speed, and then VS Code is nice enough to show me the node that contains it, so default config. So we're going to go up there to line 4. We're going to copy default config struct begin, and just like we did before with the prototype version, we're going to make sure to put the struct.end at the very end. I'm going to tab these out, and then we want to put a bpatch in here as well. Now I'm going to save that, and we can go ahead and package it again. All right, so luckily enough, we got a ladder right in front of us, so if everything worked out correctly, we should be climbing this pretty fast. Holy okay, yeah, that's pretty quick. Let's try that again. Probably a little too fast, but yeah, you get the idea. All right, so I believe that's pretty much everything I wanted to cover as far as the changes. I've gone over the major ones. I'll probably make a little bit more in-depth videos related to blueprints now that we can create self-contained blueprint mods. That's really exciting to me because pretty much all my mods have been blueprint mods up to this point. But yeah, hope to see you in the next one. Have fun modding.